Hello and welcome to another GCSE revision video, and in this video we're going to be looking at simultaneous equations. One of the most powerful methods for solving systems of simultaneous equations is called the substitution method. And the power of substitution comes from the concept of equality. Okay, so the concept of equality basically is saying that if x equals y, then y equals x. Okay, that might sound really trivial, but it's actually extremely profound, and it cuts to the very heart of algebra. In fact, this is one of two concepts that all of algebra is built upon. So I'm making a big deal of it because although it looks trivially obvious that you don't even need to give any thought to, it's actually extremely profound. So really make the effort to be absolutely certain in your heart and your head that if x equals y, then that means y equals x. Okay, and this brings us to another concept that looks on the surface to be really trivial but is actually extremely profound. If x equals y and y equals z, then x equals z. I'll just give you a second to digest that. It grows logically from the concept that if x equals y, then y equals x. Okay, so let's make use of this really powerful concept to solve a question like this that you might find on an exam. Given that y equals 2x plus 1 and y equals 3x minus 2, find x and y. Well, this all boils down to this concept of equality. If x equals y and y equals z, then x equals z. So if y equals 2x plus 1 and y equals 3x minus 2, then 2x plus 1 equals 3x minus 2. Well then, if 2x plus 1 is equal to 3x minus 2, then 2 plus 1 is equal to 3x minus 2x. You'll note all we've done is swap the terms around. I've taken the 2x from the left-hand side and moved it to the right-hand side, so it's become negative. And I've taken the negative 2 from the right-hand side and brought it over to the left-hand side, so it's become positive. And if 2 plus 1 equals 3x minus 2x, then 3 equals x. Again, all we've done here is to combine like terms, and we remember that combining like terms doesn't change the balance on either side of the equation. And of course, if 3 equals x, then x equals 3. That's the fundamental property of equality that allows us to do these simultaneous equations in the first place. So now we know that x equals 3, we can substitute this value 3 wherever we see x in either of the two equations we've got in the question. And let's pick y equals 2x plus 1. So if x equals 3 and y equals 2x plus 1, then y equals 2 times 3 plus 1. And if y is 2 times 3 plus 1, then y is 7. So our solution to the set of simultaneous equations is x equals 3 and y equals 7. In the last example, we had two simultaneous equations and we solved them simultaneously and we found one solution set. However, simultaneous equations can have no solutions, one solution, two or more solutions, or can have an infinite number of solutions. Okay, so how can we tell when a system of simultaneous equations has no solution? Well, if we take this example, 2x plus 1 equals y, and 2x minus 1 equals y, and then we try to solve it, so we go through the motions like we've already seen. If y equals 2x plus 1 and y equals 2x minus 1, then 2x plus 1 equals 2x minus 1. So if 2x minus 1 is equal to 2x plus 1, then 2x minus 2x is equal to 1 plus 1. Combining like terms then, if 2x minus 2x is equal to 1 plus 1, then 0 is equal to 2. Well, clearly 0 does not equal 2. This is called a contradiction. And if you try to solve a system of simultaneous equations and it results in a contradiction, then you can confidently assert that there are no solutions. And how can we tell if a system of simultaneous equations has an infinite number of solutions? Or put simply, if you have more variables than equations, then you have an infinite number of solutions. Sometimes, though, the maths can be a little bit deceitful. If the second equation is just a rearranged version of the first equation, you still only have one equation and two variables. So there's still an infinite number of solutions. It just looks like you've got two equations and two variables, but in reality you've only got one equation and two variables, because the second equation is actually just a rearranged version of the first equation. Sometimes it's even less obvious. Say in this case we'd have to divide everything through by 2 in order to get to the first equation. So if the second equation can be algebraically manipulated in some way to become the first equation, we still only have one equation and two variables. In general, if you have more variables than you have equations, then you have an infinite number of solutions. Okay, well, so much for the theory. Let's have a go at putting that into practice. Let's take something like 3x plus 5 is equal to y. And let's try something like 2x plus 1 is equal to y over 2. Okay, let's start by rearranging this so that we can either get x on its own or y on its own, and then we can use the substitution method and just substitute the value. So in this case, let's double this equation. So that becomes 4x plus 2. So 2 times 2x is 4x, and 2 times 1 is 2, is equal to, and y divided by 2 multiplied by 2 is just y. So now 4x plus 2 equals y, and 3x plus 5 equals y, and since they both equal y, then they both equal each other. So 3x plus 5 is equal to 4x plus 2. Now we just gather like terms. So 5 minus 2. I've taken this 2 over here, and then it's become negative because it's jumped over the equal sign. And that's equal to, and now this 3x has to go over the equal sign. And again it changes sign. So we've got our 4x, and this time the 3x becomes minus 3x. So 5 minus 2 equals 3, and that's equal to 4x minus 3x is just x. So we know that x equals 3, So if x equals 3, then we can substitute that in any equation. Well, the top one looks like the easiest. So 3 times 3 plus 5 is equal to y. Well, 3 times 3 is 9. 9 plus 5 is equal to 14. So therefore y is equal to 14. So our solution is x equals 3, y equals 14. Incidentally, if you're asked to give your solution as an ordered pair, you would just write open brackets and then x comma y. In this case, x is 3, y is 14. Okay, let's try this one. 3x minus 3 is equal to 2y. And 3x plus 3 is equal to 2y. Okay, well, right here, alarm bells should be ringing. How can you have a number that if you take 3 away from it, it equals a number, and if you add 3 to that same number, you get the same number? That doesn't make sense. I strongly suspect that there are not going to be any solutions to this system of simultaneous equations. But let's go through the motions and check. So if 3x minus 3 is equal to 2y and 3x plus 3 is equal to 2y, they're both equal to 2y, therefore they're both equal to each other. So 3x minus 3 is equal to 3x plus 3. So moving the terms around, I'm going to take the 3x from here and I'm going to bring it over to the left hand side. So that's 3x minus 3x is equal to, and I'm taking the negative 3 across here and I'm bringing it over to here, so it becomes a plus 3. So that becomes 3 plus 3. So 3x minus 3x is 0, and that's equal to 3 plus 3 is 6. But 0 cannot equal 6, so this is a contradiction, so we just write no solutions. And we can say that with confidence. Okay, let's try one more example. Let's say something like 6x plus 1 equals y. And let's say 12x plus 2 equals 2y. Okay, well, if you spotted that this second equation is just the first equation multiplied through by 2, then well done. But let's just take this first equation here and let's double it. So we're going to multiply 6x plus 1 by 2, so that's equal to 12x plus 2, and that's equal to, and y times 2 is 2y. So what we've got now is two identical equations. So this equation is the same as this equation. They're both the same equation. So we've got one equation, but we've got two variables. So we've got more variables than we have equations, so there are an infinite number of solutions. Number of solutions. Okay, I hope that was helpful. Why don't you have a go at trying out various systems of simultaneous equations for yourself using this very powerful method of substitution. I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in another video.